Good morning. Today we're doing BJU Press Pre-Algebra, section 4.5. It's titled Decimal Equivalents. We're on page 195 in the book, and we're starting with numbers 1 through 37 odd. So number 1 says convert each fraction to a decimal, and the fraction given is 3/5. We also know that this can be read 3 divided by 5. So let's do some side work over here. We're going to do 3 divided by 5. Which means we need to add a decimal and some zeros in order to make this division problem happen. So 5 does not go into 3. 0 times 5, we can do all that. Bring up the decimal point. And now we're doing 5 into 30, which is 6. Multiply, get 30, subtract, and we didn't even need any extra zeros this time. So number 1, the answer is 0.6. Number 3. We have -7/25. So I'm just going to remember that my negative is here. I'll put it down so I don't forget it later in my answer. But I'm just going to go through the long division with 7 divided by 25. We'll have to add on an extra decimal here because we can't do 25 into 7. So we'll have to do 25 into 70. Bringing my zero, my decimal up. So 25 goes into 70 2 times. That's 50. Subtract and get 20. And then we'll need an extra zero this time. Bring down a zero. 25 into 200 goes 8 times. So 8 times 25 is 200. Subtract, and we're finished. So we have terminated our decimal here. So 0.28, negative 0.28 is the answer. Number 5, we have 17 divided by 5. Okay, so this is an improper fraction, but we're going to put it into a decimal with the same method. 17 divided by 5. So 5 doesn't go into 1, it does go into 17 3 times. 3 times 5 is 15. Subtract and get 2. We don't have anything to bring down, so we'll add in our decimal, we'll add in a 0, and then we can bring down our 0. 5 into 20 goes 4 times. 4 times 5 is 20, and we're good. So our answer is 3.4. Number 7, we have 9/40. Okay, so this is 9 divided by 40. Right, 40 does not go into 9. That means we need to add decimal, bring up the decimal. 40 goes into 90 2 times. That gives me 80. Subtract and get 10. Need to add a decimal to bring down. 40 goes into 100 2 times. That's 80. This time I'm left with 20. Need another decimal to bring down. So 40 goes into 200 5 times. 200, and we're done. So we've terminated our decimal here, so it's 0.225 is our answer. Number 9, convert each decimal to its reduced rational form. All right, so 0.625. This has 3 decimal places. In fact, it's tenths, hundredths, thousandths. So we would read this 625 thousandths as a decimal. That's how we know in order to switch it to a fraction, we just need to take the number and put it over the thousandths. And then you're just going to do your dividing out. Make sure you reduce. You're going to get 5/8. Number 11, -0.8. So this is in the tenth spot. So this is actually read -8/10, which can also be written as a fraction as 8/10. And then just make sure you do all of your reducing. Don't forget about that negative in your answer. Your answer is -4/5. Number 13, we have -4.7. We only need, well, let's say there's 2 ways you can go about this. You can just say, all right, this is the same as -4 and 7/10. And then you can do what we did in the last section, which was multiply 4 by 10, get 40, add the 7. It's -47/10. Okay, if you wanted to, you could just take this and put it over right at the beginning. A little extra work there, so I think I'll just stick with this solution that I've got here. So let's do 5 and 68 hundredths is what we've got. So that can be written as 5 and 68 over 100. And then if we reduce this, we end up with 5 and 17/25. Both divide by 4. Now we're going to make this into an improper fraction, because remember, a rational form is always the form a over b, right? A over b, as long as b is not 0, but there's no number in the front here, right? So it's always the form a over b, so we have to have a fraction, improper fraction, when they ask for rational form. So we do 5 times 25, add the 17, that's going to get us 142 over 25. Number 17, how do I convert a fraction to a decimal? You're going to divide the numerator by the denominator until the decimal ends or repeats. So just putting into words what we did, divide the numerator by the denominator until the decimal ends or repeats. All right, number 19. Convert each fraction to a decimal. So we have 13 over 9. All right, 13 divided by 9 is what we're dealing with. This was an improper fraction, so it makes sense that we're going to have 1 before our decimal. Then we're going to need to add a decimal and a 0, bring all that up here. And then we end up with 4/36. Oh, I see it happening right away. You're going to end up getting 4 every single time in a 40, which means this is a repeater. So we have 1.4 repeat the 4 here. Number 21. We have -7 over 11. So 7 divided by 11, take care of these decimals. This goes in 6 times. And I can see right away again. And maybe not yet here. Let me see. Oh, I subtracted wrong. That was why. I'm like, wait a minute. Okay. Back up here. Okay, so this is 40. And then 3 is going to get us 33. Let me see if I did something wrong here. Oh, I see. Okay, so we're going to get a 7. All right, and then, wait, I brought this down. Okay, so we need to bring another one down. And that's going to get me a 6. And then we've got, oh, I keep doing that. I keep subtracting that wrong. That's going to get me a 40. And so here's where the pattern's coming in. I'm starting to see now. It's just going to keep bopping back and forth between the 6 and the 3. Okay, so we have the negative that was originally in the problem, 0 point, and the 6, 3 is what gets the repeater bar. Number 23, we have 7/12. Excuse me. 7 over 12. Okay, so 7 divided by 12. Let's take all this here. We're going to get a 5. That's 60. Subtract. Bring down a 0. And then 12 goes into 108 times. So that's 96. We got a 40. And then it's going to go in 3 times. That's 36. And we're going to add 40. So it'll be another 3. And that's just going to keep happening there. Okay, so the answer is 0.58 with the 3 being repeated. Number 25. 61 divided by 9. So 61 divided by 9. 9 goes into 61 6 times. Gets me 56. We got 50. And then 9 goes into 50. Oh, wait. Oh, yes. 5 times. It's 45. Oh, and we're going to keep getting 9 goes into 50 again 5 times. 45. Wait, did I do it? Did I mess up again? Oh, yes. My gosh, if you guys are using your calculators, you're probably making out a lot of bit better than me. But hey, we all make mistakes. Okay, let me redo this. So I multiplied around. So 61 divided by 9. 9 goes into 61 6 times, and that's 54. That was my error right here. And that gets me 70. Bring that decimal up here. And then it goes in 7 times, that's 63. And that's going to be 70 again. So the repeater is on the 7. So 6.7 repeated. All right, number 27. 27 is 3/7. So 3 divided by 7. Okay, it doesn't go in here. 7 goes into 32. That's 28. So it's 4 times. So that gets me 28. Subtract and get 2. Bring down a 0. 7 goes into 20 2 times. That's 14. Subtract and get 6. 7 goes into 60 8 times. That's 56. Subtract to get 40. Still going. 7 goes into 40. That's going to be 35. Oh, still going. 7 goes into 50. That's going to be 7. It's 49. And wow. Okay, it goes in 1 time. That ends up with a 30. All right. Interesting. Okay, so it ends up with a 30, but last time I had 30 to start, I had to go through this whole big long process, and 7 goes into 30. It's going to start all over again. 4 gets me 28. 2, it's going to end up being the same exact pattern. So this is a really long repeater. 4, 2, 8, 5, 7, 1, all repeated. That one was fun. All right, number 29. Convert each decimal to its reduced rational form. So we have 0.6 repeated. All right, we learned a whole process for this. They go over it in your book, a few examples, but we wrote down the whole process for converting the repeated decimals on the top of page 193 is where we find it in the book. So the first thing that we're going to do is we're going to set x equal to the repeated decimal. And then you're going to look at it, you're going to multiply it by a power of 10. Remember, the power of 10 is determined by how many decimal numbers are repeated. So there's 1 decimal repeated, so that's 10 to the 1, or 10. And then we're really doing this here, right? We're just multiplying this times 10. So I'm only going to write it down this time. The next time I won't write this step. So all that means is I'm moving this decimal over 1 time because I'm multiplying it by a power of 10. So now I have 6.6 repeated. Okay, then you're going to subtract this equation and this equation. So we'll bring this down. We're actually subtracting the whole thing. X equals 0.6 repeated. We're subtracting that whole thing. So that leaves us with 10x minus x, 9x, and 6.6 repeated minus the repeated 6, which means the repeated parts are gone, and you're just left with 6. Now we can divide by 9. So x is equal to 2/3. They both reduce. All right, number 31. So we have a negative 0.123 repeated. All right, so we're going to say, let's let x equal the decimal that they give us. Then we're going to multiply by power of 10 on both sides. This time it's 1,000 because there's 3 decimal places repeated. So that's going to move my decimal over 1, 2, 3 times, but it's going to keep repeating the 1, 2, 3. Now I'm going to subtract the new equation and the original equation. So minus x equals negative 0.123 repeated. So we're going to end up with 999x equals, repeaters are subtracted out. So it's, okay, so they did not put the negative in here. Well, I guess it doesn't really matter. I don't have the negative in my work, but it's in the answer, right? Of course. Okay, so we end up with negative 123. We're going to divide by 999 on both sides, and then end up reducing. So they both divide by 3. That leaves us with negative 41 over 333. Number 33. Problem looks very similar, but there's only one repeated number, one repeated digit. And this time it's just the 3. So we've got x equal to the decimal that they give us. And then we only have one repeated decimal. So that means we're only going to multiply by 10, which only moves this once. So we have 1.23 repeated. Okay, so now we're going to subtract the original equation. I'm going to have to adjust my number just a little bit. I'm going to get rid of this repeater so that I can subtract these guys here. And just put it 1 over because that's what it is anyway. So we're going to have 10x minus 1x, that's 9x. And then when we subtract, these are gone. We end up with a 1.11. All right. I don't like to see these decimals in here, so that like part of my fraction, like, so I could divide by 9 and, you know, have all of that, or it's probably just as beneficial right now to get rid of that decimal. I can get rid of this decimal by moving it 2 times to the right. As long as I do that on this side of the equation, though, I have to make sure I do it on that side of the equation. That would make it be a 900 because I moved that decimal twice. Divide by 900. X equals, and if we reduce, 37 over 300. Both divided by 3. Number 35. Order the numbers from least to greatest. So we originally have 0.32 repeated, 0.318 repeated, regular 3.2, 0.32, also 0.318 repeated. I feel like I keep saying the same thing. It's just different parts being repeated. Okay, so here's what we have. Okay, I'm going to go 3 decimal places on each one. Let me make sure I was writing down the wrong one. Oh, my word. I wrote down number 36. I did not have my coffee yet this morning, Katie. And she's laughing. Okay, whoop. All right, I'm done with that scribble. Okay, so number 35 is 0.172, 0.1 with 72 repeated, 0.17 with only the 2 repeated, and 0.172 where they all are repeated. Okay, so let's do 3 decimal places on all of these, like I was starting to say. So this one is 0.172. There is nothing repeated, but I'm going to put some zeros in there. The second number in my set is 0.172 with just the 7 and the 2 repeated. So that's 0.1727727, and it would keep going. And then 0.17 with the 2 repeated is 0.1722222 going on, and 0.172, all of it repeated, 172172. All right, so we've got this row here. We've got 1s, 7s, 2s. Here's where we're changing. Oh, this made it super easy, because 1 is the smallest, and then this decimal place of 2, and then, oh, I'm sorry, this decimal place of 0, then this 1, then this 2, then this 7. So that was pretty easy. Okay, let's just make sure we write the original number from the set, not this expanded version. So 0.172 is the smallest. Then 0.172, where it's all repeated, would be next. Then 0.17 with just the 2 repeated. And finally 0.172 repeated. Number 37. Whoops. Number 37. Okay, instead of rewriting the original here right from the book, I'm just going to go right into expanding them. So 0.54, 0.45 repeated, 0.54 repeated, 0.45 repeated, 0.405 repeated, 0.456. Oh, this one is just 5/6. Okay. So let's do 3 decimal places. So 0.540000, 0.455555, 0.54s, repeat the 4s, 0.454545, and then 0.405405. Then we have 0.456565. Okay. Anything with a 4, we're going to do first. But we do have to go to the second row. Okay, so this guy's going to be first. This is 1. So 0.405 repeated. What would we need next? Let's do the 4-5 repeated, 0.45 repeated, and then we just need this guy because that's just the 5 repeated. Then we're going to have this one, 0.456 repeated. Okay, moving on to the ones that have the 0.5. So next would be 0.54, the one that terminated, and then the one that repeats the 4. Okay, moving along. So 1 through 37 odd. And then what are we doing? 43 to 51 odd. Okay, solve each equation. Negative 90 equals negative 6y plus 12y. All right, there's my equal sign. My y is over here on the right side, and there's multiple y's. That means they are like terms that need to be combined before I move from one side of the equation to the other. So negative 90 and equals, those are all staying. This is going to end up being a 6y. And then we divide both sides by 6. So that gets me with negative 15 equals y. We usually write the y first, so I'm just going to rewrite it. Y equals negative 15. Number 45, negative 7y plus 6y minus 12 plus 4 minus y equals 2. All right, so there's the equal sign. I've got a bunch of y's on the same side of the equal sign. Those are like terms that need to be combined. Also have some constant numbers that can get combined. So I end up with negative 7y and 6y, that's negative y, and another negative y is negative 2y. Negative 12 plus 4 is minus 8 equals negative 2. Then I'm going to add 8 on both sides. Negative 2y equals 10. Divide by negative 2. So y equals negative 5. Okay, number 47. Write and solve an equation for each exercise. A lunch buffet costs $9 for adults and $5 for children. If a group with 3 more adults than children pays $97, how many of each are in the group? All right, so let's start off with, they tell us that there's 3 more adults than children. So they tell us something about the children. So let's start with letting our variable be C. C is the number of children. They also tell us that the number, there are 3 more adults than children. So that means the adults is the children plus 3 more than children. We also know that, let's stick with, this is probably going to be important here. So we also know that it's $9 for an adult, plus it's $5 for a child. And the group pays $97. Okay, so what we're going to do is some substitution here. So C plus 3 is going to go in place of this A. So we have 9 times the quantity C plus 3 plus 5C equals 97. We're going to need to distribute here. 9C plus 27 plus 5C equals 97. All right, so here's my equal sign. I've got C's. That's going to be 14C plus 27 equals 97. Subtract 27 on both sides. 14C equals 70. Divide by 14, C equals 5. Let's just make sure we answered the question. How many of each are in the group? So this means we've got 5 children. And the adults we discovered up here was children plus 3. So that means we have 8 adults. Number 49. Find the GCF and LCM of 24 and 99. 24 and 99. Okay, so why don't we try to do a factor ladder here? So 24, 99, let's see what we could come up with. They both divide by 3. So that's going to give me 8 and 33. you know what? Let me see. Nothing else is going to divide out of them because 8 is 2, 2, 2. Okay, so let me do the 24. The 24 is going to be 2 cubed times 3. And the 99 is going to be 3 squared times 11. Okay, so here I've got my GCF. I found out that my GCF was 3 from my factor ladder. And then my LCM, I'm going to just use the highest of each one of these here. So LCM is going to be 2 cubed times 3 squared times 111. And that's going to get me 792. Number 51. Was I supposed to do that? Where's my list here? 51 and 52. Number 51. Which pair of numbers is not relatively prime? Here the answer is D. And 52. Compare the fractions 6 sevenths and 20 over 21. What I want to do is make my fractions have the same denominator so that I can compare them. And I know that 7 is a factor of 21. If I just multiply that by 3, I'm going to get my denominators to match. It's just that I have to make sure I do it to the numerator as well, which gets me 18. So really now I'm comparing the 18 to the 20, and that's going to be a less than, which means my answer is C. All done.